install it. And I mean, installation-wise, it's pretty straightforward, just as any other prepackaged software. So I hope most of you should not have a problem. If you do, then the best resource to troubleshoot would be just Google, first of all. Google the problem and try to get a solution there. It's unlikely that me or anyone else participating would have necessarily faced the same issue as you. And if that doesn't work, you can still post it in the forum or one of these places, either the question sheet or the activity page, wherever it's all right. Okay, so other than that, okay, let me take a couple of polls. First of all, I would like to know how many of you have already used Stellarium before, not just when you download it for this particular course, but even before that. Can you raise your hands? I'll give a few minutes. Okay, I see about 30 participants raising their hand. Okay, that's a fair number, but still small for the actual number of people really participating, which is not too surprising. For many of you, especially students, it might be the first time you're interacting or getting to listen to courses for lectures and stuff related to astronomy. So it's no big deal. But I'm sure you'll have some idea of what actually goes on in astronomy by now, at least due to the lectures and maybe some sort of recreational activity that you did during school. But it's a very easy, free to use software. It's fully featured. There are plenty of features that many of the people who have used it for long have not even properly explored. For instance, I've known of the software for probably 10 years or more. But I recently came back to it and I saw there are all these new features right now that allows you to essentially simulate observations, graph data, and things like that. Make automate observations, which I've never used it. I hope to explore it sometime. But the features keep on expanding year after year, and there's plenty more. What we are going to sort of demo over here is just a very small percentage of what capabilities this particular software has. So, it's a good thing. Our goal here is to just get you started with the software, essentially tell you that this resource exists. The worksheet is created so that one can work through it even without any sort of lecture like this one or a demo. Most of these questions really walk you through the whole experience. So it should be okay even if you share it to some of your friends who are not present right now. And of course, when you're later working with it, it should be pretty easy to understand, I hope, for the most part. If you do feel that some of the language is ambiguous or there's some confusion as to what the question is trying to ask, then you can always send me an email at nrciu@gmail.com or through one of these various forms and pages, and I'll try to improve that. Okay, other than that, you guys can lower your hands now, people who had raised their hands. I would recommend that most of you should try the desktop version, just because as far as I know, it has the most features, and it can, one can also download a lot more data and work with it. Even for this activity, I think there are at least some questions where I've heard in the past some of the participants having issues when trying to use a mobile version. If you absolutely cannot download for whatever reason, it's not working on your computer, you can try to see how far you can go with either the web version. There's a web version that works on the browser, and there's a mobile version that you can download and try to use. But other than that, as I said, it's best to stick to the desktop version. Okay, so stop my video and let's jump right into it. Okay, I hope that most of you had some time to go through the worksheets, at least scan through it and see what all it asks. My guess is that it might take you a few hours to complete all of this through, especially if you do not have experience with it. So try to do it, whenever you get time throughout this school or course. Try to do it bit by bit, maybe a couple of pages whenever you get time, and you should be able to finish it before the end of the school. The summer school participants are not really expected to submit any of this. You can just do it at your own leisure. I'm sure you'll enjoy it, considering you have put in the effort to join a summer school for astronomy and astrophysics. You should enjoy it. People who are participating in the refresher course, as you are part of that Moodle platform, there are instructions given over there as to how you're supposed to submit it. You essentially will have to work in groups and then submit it by group. And there's a deadline of 30th May. And as I have already said, it's better to get started early. This is going to be an orientation demo. This should help you get started very easily. And if you have any questions that you encounter while you're working with it together in a group or by yourself, you can always post it in the forums that are available in that platform. And I'll try to answer them as promptly as I can. Okay, I'll get started, and then maybe in between I'll take breaks and answer some questions if I can. Okay, so once you start your software, you'll see something like this. It will default, hopefully it should default to your current time because it takes the time from your computer. And then it will show a default ground image and the sky. If it's the daytime, it'll look something like this. Now, there are a whole bunch of options on the left and bottom, and a few on the top right over here. Okay, if you do see that, there are a couple of things I should announce beforehand. If you see there's some problem with the graphics here, if you cannot see my cursor or whatever, you can message me here as a direct message. I'll try to keep an eye on it, and if there are some errors, I can rectify it immediately. Also, my internet sometimes last few days, I've been noticing that it has problems while connecting to Zoom. It sort of breaks in between for a few seconds. If it does, you cannot hear me, or it seems that the screen share is just static, stuck. You can just wait a few seconds. I'll try to connect back. Okay, so this is what you'll see. A lot of these things, the options that Stellarium gives, you'll get a hang of it once you just start playing with it. While you go through the worksheet, I suggest that a lot of these questions do not give very direct instructions as to this is exactly what you need to do to get the answer. But it does encourage some sort of playing around with the controls. It'll tell you what particular button does what and what options are there which might be relevant to answer the question. So if you work around with it a bit, try a bunch of options here, you'll get a hang of it in just maybe a couple of hours or so. It's the learning curve on this software is pretty shallow. So the first thing to check would be, you would want to replicate something that is close to the sky that you would see if you just go out of your house at your location, right? So the first thing would be to set the right location. Stellarium allows for a user to stand pretty much anywhere on the Earth's surface. So if you take the first menu, which is for location, and if you click on it, you'll see there's a map, there's a search window for the location. You can enter latitude and longitude. If you can use Google to find your exact latitude and longitude, you can do a whole bunch of these things, and then you can set it so that it is set at your current location. You can also add it, use the current location as default. If you turn this box on, every time you open, it will default to this location. And if you go somewhere else, you can always click on return to default location, and it will come back to it. So it's a useful feature to have. Right now, it's set for Pune because that's where I am. And And the time is obviously it's showing the current time, taking it from the computer. So you'll see that the bottom menu, it minimizes itself, but it has a whole bunch of indications over here. One is the date and the time over here. Time is the local time. This will use in some of the activities. This is the field of view, which is from left to right. What is the angle you're subtending? What angle you're accessing? What angle of the sky? This is about 60 degrees. I think it defaults to that. If you see any of these do not match your current date and time or the time, okay. So I guess at least one of you could not hear me clearly. I hope that wasn't a problem for all of you. I'll try to speak up a bit. Okay. So if you see that any these numbers do not match your current date and time, or it does not match the date and time required by a particular question, you go to the next menu item on the left, which is the date and time window. And this is a window we'll use it quite a bit here, because this is essentially a time machine that lets you go backward and forward in time to do a lot of things, observe a particular thing at any point in history, or try to see how it moves forward in time or backward in time. So all those are set fine. And there's sky and view options. We'll come to it as we go through the demo, I guess. So, and here, okay, these should be the latitude and longitude. So we are facing south, we know because it's marked here. If by default this thing is not marked, you have an option to turn on the cardinal points. You can see at the bottom window. Now, these cardinal points are essentially the north, south, east, and west. And it also has, further divisions: southwest, southwest, south, southeast, and so on. You can always use your mouse to, move it around. So the first thing to do would be to orient yourself and try to see where the cardinal points are. So that is what you would imagine you would do if you are actually out doing an actual observation, right? Try to orient yourself and try to see which directions are which. Only then you can talk about other objects related to that, related to these positions. So we have this. Observations are best done at night. So I'll jump to a nighttime, say start 1620, and we are here at night. So this is the night view of the sky. You can, of course, zoom in or zoom out. Now, okay, you have oriented yourself, you know which directions are which. Now the thing is, other than the apparent line where the Earth and the ground appears to meet is called the horizon. And this is your local horizon all around you, where the sky dome seems to end. And you have a well-defined north and south. Similarly, what you can do is, it's much more clearer when you're doing observation, the real sky, where you look directly up and that would be your zenith. Now, what you can do is, now you have 3 points that you know very well, north, south, and the zenith. You can draw your meridian, which is the line that connects from your local north, wherever you're standing on Earth. You take your north, you take your south, connect it to the point directly overhead, that's the zenith. And that would be your local meridian. Now, to turn on that, I think you'll have to go to sky and viewing options. And there's a panel for markings. And in the markings, there is this meridian. And the first box over here is to show the meridian line, which we obviously want. The second one, what does it do? It puts graduations on it. Yeah, show partitions. The other one is to label the partitions. Yes, let's keep all of it. Why not? So this is this is the real benefit of using this software, as opposed to going outside and doing it. I mean, there is some romanticism to actually going out and doing it. It's much more fun, and I mean, it's the real deal. But if you use a simulation software, especially a good one like this, it can take you even beyond. I mean, these are the lines that you cannot really, draw on the sky, except if you have some sort of software which augments it so that you can see it in augmented reality. But I mean, if you do go outside, you can imagine a line like this, which goes from north to the south, the cardinal points, going through the point directly overhead, which would be here, which is marked as 90 degrees. We'll come to the degrees in a minute. But this is your meridian line. This is useful right now. So what we have established is these lines which will be useful to see how things change in the sky. Only if you have some sort of reference coordinate system that we can use, we can try to measure other things with respect to it. So this is a very local coordinate system where we define this meridian. We'll come to the meridian, as I said, it goes from the horizon, crosses the zenith from north to south. And the angles that one can mark angles over here, marking 0 at the horizon and 90 degrees directly up at the zenith, and divide it into these 90 degrees in all directions, and that will be your altitude. So locally, you can define altitude of a particular object in the sky by essentially measuring the height above which a particular object is over the horizon. Now, meridian is something drawn from north to south. You can imagine similar lines that go all around. I'll turn on the graphic in a bit to show that more clearly. But an altitude is defined according to this, a line that goes directly perpendicular up from the horizon up to the zenith. Okay, now you have that. So what one can do is one can quickly see how the stars would, now that you have reference points, you can try to see how the stars would move compared to just reference points. So what you will use is this, time increment or decrement panel over here, which allows you to go forward or just backward in time with varying speeds. So one click and you can see that the seconds are going really fast. It's going about, I think, 10 seconds per second or something like that. And if you increase it further, it almost goes, I think, a minute per second, and you can go to 10 minutes per second and so on. It'll go even much faster, but for now, we'll just keep this. And you can see that now that we have these graduations and time is going much faster, you can see how the sky moves. I mean, it's something where you have learned in your school that things rise from the east and set from the west, except it's not exactly at the cardinal east. Everything rises from anywhere in the horizon, eastern horizon, which goes all the way from north to south. And then let me turn off the atmosphere so that it's always pretty much dark sky, at least for now. So here there's an option to turn on or off the atmosphere, which takes away this Rayleigh scattering that gives the blue sky, the blue color of the sky. So if you turn it off, you see this. This is what you would normally see if there was no atmosphere, for instance. So stars, all the objects in the sky, they don't all rise in the east. They rise somewhere along the eastern horizon, from all the way from south to the north. And at some point, they will transit the meridian line, and then they'll set it somewhere in the western horizon, not always on the west, not exactly on the west. What you can do is you can move to the northern direction of the sky. The importance will be apparent immediately. If you look at the northern part of the sky, especially, since we are residing in the northern hemisphere, it is the northern part of the sky which has importance for us. If you're in the southern hemisphere, one would have to look at the southern part of the sky to see something like this. So what you see is overall, when you were facing the south, you saw that the stars were rising, transiting meridian and setting. But here something interesting is happening. There is a point around which the stars seem to rotate. Now you'll see that as you go farther and farther, there's still a lot of stars over here, which do not really rise or set. They just go about in circles in the sky. And these are called circumpolar stars. And if you turn on the constellation, these are the circumpolar constellations. They would be the circumpolar constellations. Now, these are stars in constellation that never rise or set for a particular location of observation. This obviously changes as we move to other locations on Earth. Let me quickly turn on the constellation as well. There are three options for constellations. The first one turns on the constellation lines. You can see this is the Western culture constellations that's set by default. And turn on their labels, that's useful. And maybe even the arc, it just looks beautiful. So now we'll turn this off. And if you want to get more precise about where a particular constellation ends or rises, one can go again to the sky and viewing options and go to star lore, which gives an option to change between various star lore cultures. As I said, the default is Western, but you can try a whole bunch of other ones. For some reason, either it's incomplete or and many of these are incomplete in some way that a lot of these, if you select, there will be only a few constellations that they will have a proper name or image for. The rest are just regular stars. Western seems to be quite extensive, at least as shown in Stellarium, in terms of dividing the whole sky into all these constellations. So what you can do is there's an option for show boundaries. If you click on that and close this, you'll see that it will define some sort of boundary for all the constellations over here. This, I mean, we'll come to the use of this. It's essentially only in Stellarium if we want to precisely see where a particular object is, whether it's in constellation A or B, such things might be useful. And if an object moves across the sky, as we'll quickly see, across the constellations, then again, it's useful to have these boundaries on. Now, okay, you see that this is what is happening. So, I mean, for most of you, it must be obvious why this is happening. The reason for this is essentially the rotation of the Earth, right? The cause of day and night is the rotation of the Earth, and that is what is happening over here. The Earth is rotating, the sky stays still, but since we are, put it on the Earth, we observe as if the sky is rotating about a particular point. What exactly is happening is the Earth is rotating about an axis, the spin axis, and the sky appears to move if you're stuck on Earth. Now, this spin axis, as you can imagine, can be extended all the way to the sky. If you extend the Earth's north pole onto the sky, you get to a point that is the north celestial pole point. I think the point should be... Okay, we'll come to that. It's not exactly on Polaris, it's slightly shifted from it. You can sort of look from the spin itself, it's somewhere over here. So that is where the Earth's north pole extends and points in the sky. So for all northern hemisphere observers, you'll see a point on the sky which will never move because the Earth's axis points towards it. And as you go farther and farther away, it will seem to move much faster around it. So again, you can, Stellarium allows you to actually go to the North Pole, stand there and try to see where you would see the North Celestial Pole point. But it's not a very hard exercise to, just imagine where it would be if you actually are the North Pole, the North Spin Pole of Earth, and you try to see where the celestial pole point is. You can imagine where it is. Similarly, you can try to imagine where this point will shift if you are going to the equator. So equator is equidistant between north and the south pole. And again, you can imagine similarly you can go to the south pole. So these are some of the questions you would have to answer. Either you do that. So I have this question in the chat asking about how to turn off the details about a clicked point. I think when you by default click on something, if there's a star over there, it will take you. There's like a heads-up display that will come here, which will show you various details about that particular selected object. I think if you can click on the ground, or no, you really just have to find some spot which is devoid of stars, and if you're lucky, it gets away. I don't think escape works. Okay, I'll maybe take a few questions now if you have. You can see there's a question in the chat asking about how it's rotating. Please repeat. So yeah, so what we did is we essentially increased the rate of advancement of time. That is what you can do in this bottom right side panel. So there are these controls over here: the fast forward, the rewind, the play, and coming back to the original or your current time and date. Okay, I can see a lot of questions in the chat. Or even answers. Okay, if no one has any questions to directly ask, I'll move on. Okay, so what we have identified over here is the North Celestial Pole point, which means that you can have something similar for the equator, right? So a lot of this, I remember Shomak also discussing as he was giving the intro to astronomy and astrophysics on day one, where he was showing you the celestial sphere, which is this imaginary sphere. It's much more sort of intuitive from here. You can see, you can imagine a sphere that is moving around the Earth, and that is what the celestial sphere is. Now, what we want to do is, just like we identify the North Celestial Pole point, 90 degrees from that point should be the equator, and we can turn that on using the sky and viewing options. Go to markings, and you select equator, defined with respect to J2000, the year. So once you do that and change your, let's say, field of view, you'll get this. Let's turn on a whole bunch of other things. So I'll turn on boundaries for now. You can see other things clearly. Yeah. So again, if you look at the northern sky, there's a point that is that seems to be stationary, corresponding to the north pole of Earth. Similarly, there is this line which you get by directly extending the equator of Earth onto the sky, which is called the celestial equator, and that is marked over here. And to see how the daily, for day to day, how the stars position change in the sky during the course of a day, all you have to know is see is how things change with respect to these two lines. So you'll immediately see that you can make another refinement. It's not just everything is rising from the eastern horizon. But more importantly, you'll see that because the equator is defined according to the Earth, and Earth's rotation is what we are seeing on the sky, all the stars will appear to move parallel to this equator line and then set. So everything is uniform motion over here. Things are not there are loose statements that are made when you're especially studying in school, where people say that things rise in the east, they go directly overhead and then set in the west. That is true only for some of the stars on a given particular day. Actually, that may not be even true for those. But directly, you can see that if something directly rises from the east, it will go along the position of the, along the line of the equator, celestial equator, and it will cross the meridian point, not directly overhead, but at a particular angle, and then set directly over the west. Only if you're on the equator will you have this condition that the celestial equator will be directly overhead, going through your zenith, where things will rise from the east. If they do rise from the east, exact east, they will go directly overhead and then set in the west. Okay, so this is one important thing to realize. I hope that's clear. So if you're making an observation even from morning to, sorry, not morning, let's say, evening to morning, and you try to see how things move, this is all you'll see. You won't see any significant relative motion of these stars or any other objects, except maybe these fast moving artificial satellites that we won't talk about. So you have the moon. Next, the important things to locate is obviously the sun. We'll go back. So if you want to come back to the regular passage of time and if you want to come back to the current time, date and time, all you have to do is click this particular icon over here. If you want things to advance at the regular rate of 1 second per second, you click on this play button, and then back to where we were today at this date and time. We can turn on that briefly, and you have the sun. Now what we'll do is we'll focus a bit on the sun, try to see how that moves in the sky. So, I'll turn on the constellation boundaries. And you can see where the sun is right now. The Aries. Yeah, I think it's it. Let's get rid of the ground as well, which you can do in here. I mean, it will give a false impression of what is visible in the sky and what is not. Obviously, if you're in any location on Earth, there'll be a whole region of the sky that will never rise or set in your sky. So you need to be careful when trying to look at things without the ground present. But for some other activities like the ones we're going to do now, it should be all right. So what you'll see is that the sun is currently in the constellation Aries. Yeah, Aries, the ram, which is depicted over here. This is the boundary, and this is where the sun is. And if you want to see, so during the day, you'll pretty much see it right there. The movement of the sun will be barely noticeable, and it will always move parallel to the celestial equator, rise and set. But what happens if we change the time? Okay. One other thing, if you want to keep the sky stable while you concentrate on a particular object, you might have to select center on selected object in the bottom menu. Look at the place where the my cursor is hovering. So if you click on that, it will center it. And then if you change the dates and times, your whole sky won't go left and right. I mean, at least your view will be exactly on the sun while the things move. If you don't do this, sometimes the sun might veer off away from the screen, and you might have trouble keeping track of it. So what you can do is now even go hour by hour, or no, that will cause some confusion. Let's go day by day. So you can select it and use the arrow button. And this sort of reorienting of the sky is because it's still assuming that you're standing somewhere on the, we are still using some sort of apparatus which is fixed on the Earth Earth's ground. And as the sun rises and sets, the orientation of the sky with respect to that person will keep on changing. So that is why it changes. But even this can be handled. I think this is originally what we had. We choose an equatorial mount, it will try to counter the effects. We'll keep it at this. Now let's try to increase. Yes. Go a little far away. It will run hard so that it's clear. Okay, now I'm increasing. Select this. Stellariums, and we advance in time. So you might have to advance slightly faster, and then you start seeing the sun move. You can see that by, oh, I'm changing the hours here. So this is hours, this is date. So we are in the 18th. In a few days, it will move out of Aries. And if you increase the days, you can see that it just smoothly moves over the constellations. And you can see this progression of constellations. If you try to see the names and the artwork, you'll recognize them easily because it's all permeated in our culture, in various cultures actually. So it will be the 12 Zodia constellations that you're aware of. And you can see that the sun, with respect to the star, will keep moving in the sky as the date progresses. The stars themselves are quite far away, that even though they have slight motions, those motions won't be visible for the scales of days and years, months and years. The sun appears to move in the sky because the Earth is rotating around the sun. That essentially is what's happening. And we have defined the days and year so that it's convenient for both daily timekeeping and yearly timekeeping. So that throughout the year, the position of the sun in the sky keeps on changing. This need not be, I'll come to that in a bit. We have set it so that so we have set it so that it's convenient that during our days, the sun is at the peak altitude at noon. We'll come to the demonstration of that in a bit. And then we have because we have set the days like that, and we have used an integral number of days for a year, that automatically means that we'll see the sun at different parts of the sky throughout the year, which is good for yearly timekeeping. Not in current society maybe, but in earlier civilizations, you can imagine if you're entirely going by the position of the sun and using the sky for timekeeping, then it's a very useful thing to have, rather than have a system where you're looking, the days are defined such that you're essentially keeping track of the stars, and the sky, essentially the distribution of the sky doesn't change every day at a particular time. So you can see that the location of the sun changes throughout the year going through the zodiac constellations. You can see other things whizzing past as well, which are these constellations, which are these planets. Now, that is one of the reasons these constellations were quite useful early on. It gives a very good background for you to track changes in the sky. So you can see where the sun is in the sky. Either you look at the dawn or dusk and try to see which constellations are nearby and try to guess which constellation the sun is, because you cannot directly look at it. Or you can use the moon, for instance. You can see which constellation the moon is and try to keep time according to that. You'll see that what ancient civilizations did observe is that there are a whole bunch of other bright objects that are moving around with respect to the stars. The stars are pretty much fixed during the course of a year or even few years. but the position of these objects, some of them seem to change within days, some of them within months, and some of them in years, quite visibly. And that is how they discovered planets. And its name essentially comes from the word wanderers. And you can see over here, there's Mars, there's Venus, there's the inner solar system objects. And if you search for the outer ones, you can go to those as well. For instance, you can search for Jupiter. And you'll see that even Jupiter will move with respect to the stars. Its motion will be slightly more complicated. The ones that are beyond Earth, they will sometimes show retrograde motion. This is essentially because our orbit is smaller and the orbit of Jupiter is much larger. So we are observing Jupiter from two different vantage points on our orbit. You'll see that sometimes it seems to go in the opposite direction, but obviously it's not doing that. Okay, so I see a few hands up. Maybe I'll take a few questions. Yeah, Purvi? Yes, you are. Go ahead.
Yeah, I just wanted to ask if there's a way to calculate the distance between 2 points, the separation between 2 points, like in arcseconds in this.
Actually, there should be really a proper, clever way to do it, I'm sure, which I haven't figured out. But this, one crude way of doing it would be to set one of these grids. I'll come to these systems. Here you can, if you turn on a grid, then there are these angles that are marked, and you can approximately get a distance. But I'm pretty sure there is some way to actually measure the distance. You'll have to look into the manual of it. They would have established this somewhere that you can actually make a measurement.
Okay.
As I said, I haven't done a lot of research into all the capabilities. It really has a lot of capabilities. So I wouldn't be surprised if there's a better way of doing it.
Can you open any custom fits files? Can you open any custom fits files in it? As in, like for the first.
As far as I know, it doesn't allow you to do that.
Okay.
There is a software DS9 which you would know, right?
Yeah.
Yeah, DS9 is what you can use. But I can see the merit of it. I can anticipate what you're trying to say. If you can open a FITS file here and it can put it right there against the sky, it would be really amazing.
Yeah, exactly.
But as far as I know, it doesn't allow that. But I do go ahead and do a Google search, I'm sure. If somebody is trying to implement some sort of plugin, there's an option for plugins too. If somebody has written such a plugin, you might have to install it separately and make use of them. That would be a cool feature. Yeah.
Okay. Yeah. Sure.
Yeah. Astha?
Yes, sir. Am I audible?
Yes.
Yes, sir. Suddenly, I have lost the sight of all the planets and sun as well. So, how to get it back?
Oh, you lost the planets?
Yes, sir. Only constellations are visible.
Oh, okay. Actually, there is here. I think, I faced it myself at times. So can you see the cursor is on the bottom panel? There's a one for planet.
Yes.
Oh,
yes,
sorry,
sir.
that is planet labels. But do you see the planet?
Yes, sir. Planets were visible, but I guess sun was not visible.
Did you do a search? I'm sure the sun doesn't disappear ever.
Yes, sir. I searched as well, but it was shown like it was
might
not
be below ground. I don't know. Anyway, this sort of troubleshooting. All I wanted to say was there are some. You'll see that many of these options have shortcuts, which are essentially control plus some letter, or in some cases, I think they are just single letters. So if you accidentally press it while you're searching for something, it has happened to me where I'll press something like I and the image of, I'll show you later, image of some of the deep sky object just disappears. So what you can do is you can, play around and try to get it back somehow by pressing different letters that you might have pressed.
Yes, sir.
Or sometimes what I do. Sometimes what I do is I just restart the Stellarium if I cannot get back to the original.
Yes, sir. I guess
then it usually defaults to whatever it's supposed to have, and then the planets and all these things will come.
I guess I'll restart it again.
Yeah. Ishwaran?
Good evening, sir. Am I audible?
Yes, you are.
Sir, certain stars are not visible at region due to low luminosity or scattering due to atmosphere or light pollution at the region.
Yes.
So whether there is any option which shows only visible stars that can be seen from a location?
Oh, yeah. So not exactly, because it wouldn't know what is the level of light pollution in your sky or haze in your sky. So other than that, what you can do is, so if you see the screen right now, I started this sky and view options. And there's a way to activate atmosphere visualization. And what this does is try to, incorporate all these effects of the atmosphere. And you can change the amount of light pollution. Let me go to a time that is night. I'll come back to it. I'll make it more realistic. No, this is fine. Okay, we look at the northern region of the sky. Not too many bright stars there. We'll turn off these markings too. No, not this. So now you can see, this is, for instance, in Pune, you'll never see the northern sky like this. So let's say we want to get a more realistic view of what we want to see. What you can do is you can up the light pollution. There's even some local database available from which it can read it. I think I don't know how.
Okay, sir.
It's not it. But you can definitely increase it and try to simulate it. See, you can go all the way up. You can go to a very large number where you won't see any stars. But a number like 6 or 7, for instance, will wipe out most of the stars. And this might be more close to how you would see it on a,
So if we know the light pollution rate of at a region, we can adjust the.
Yeah. Right. For specific cases where you exactly want to see how the sky looks on a particular day in your local sky, but then it sort of loses the purpose of using Stellarium.
Okay,
but you
sir.
have the option. Yeah.
Okay, thank you, sir.
Sure. I'll take one more question. Jyotirmay?
Yes, sir. Sir, am I audible?
Yes, you are.
Sir, actually, you have only 2 classes in this course. So therefore, I expect that in these 2 classes, you will explain this the function of this keys like SSO, DSO, surveys, and these astronomical calculations. It's all the functions of this menu.
Oh, you're saying that you would like to hear more about these various options?
Yes. One by one.
Oh, actually, yeah. We probably cannot do it right now. In this particular course. These new ones, I only recently saw that they have all these options. The astronomy calculations window. You mean these? A lot of these I've never tried it. I would like to try it at some point and create modules for it. But right now we'll just do the basic one. But in the future we'll develop these things perhaps. Other than that, it's a free software. I think playing around with a lot, will make you learn it by yourself.
Like
and
DSO,
I'm sure there are things on. Excuse me.
Means purpose of this menu of like DSO and functions of DSO and surveys.
It was. Unfortunately, it won't be part of this particular course. But I would say it's best to Google. A lot of this information is available. Google is just all scattered in different places, perhaps. Any survey you want to know about, Google is your better bet. Okay, sorry about that. Perhaps in the future, we can try to create modules which go much deeper into it for especially the advanced courses. Okay, Shreya, you wanted to ask something, or did you ask already? I forgot.
Good evening, sir. Sir, I would like to ask that using this software, do we really need a keyboard to operate this? Because I am using a touch a tablet, so I am not able to use the screen keyboard to do some operations.
Okay, for search, you will have to use, but I guess if you do the search over there, it should bring up your keyboard.
So the touch
Other than that, even for a
because
desktop
not
version, I
allowing-
never had to use the keyboard. I pretty much use my cursor for everything.
Okay.
Okay, I'll try to show a few more things and then I'll take questions because all these are more like technical things about how to use it. Okay. So, okay, we saw how the meridian is defined. Briefly saw how altitude is defined. So a local coordinate system can be defined using a combination of altitude, which is the height of something above the horizon. Now, when I say height above the horizon, it's a bit hard to do because it's spherical space that you're trying to map things on. We have to know that if you're working with the surface of the sphere, the straight line is essentially part of a great circle. So whenever I say height above the horizon, you should imagine a great circle that goes above a particular point, above a point on the horizon to that particular star, and the angle that it subtends would be the altitude. Now, the other coordinate that we can define is called the azimuth, and that would form part of the azimuthal grid. So this is a very local coordinate system. This will look identical no matter where you're standing on Earth. It will have these zeros and these lines defined according to the local horizon and your zenith, which will not be the same for different observers from different positions. But locally, for observations, it's very useful. Even for professional observations, you want to know how high above the horizon a particular star is for you to be able to observe and reduce the effects of atmosphere and or air mass and light pollution. So it is still used for various sort of observations, but you can see how the altitudes are defined according to these circles that are concentric to the horizon. These look very much like latitudes. And then you have the azimuth, it starts from the north as 0, and it goes westward to increasing degrees back to 360 degrees or 0 degrees again over here at the north. So it covers one complete circle. So you can imagine altitude and azimuth of various objects. For instance, if you take this bright star Antares, the altitude would be this angle, which seems to be approximately, a little less than 40 degrees and a little less than 180 degrees azimuth. And these values also given here. We can see that the azimuth altitude is little less than 40 degrees. That's right. Now, why is the azimuth 208? Okay. I think right. Sorry, I think I explained it in the. So I switched it. Azimuth is defined from the north going eastwards. So that north to east going through eastward, it becomes 180 degrees here, then 120, 128 over here. So that is the azimuth. So this is a local coordinate system, but as we saw, we have a very unique point defined, which is the North Celestial Pole point, according to the North Pole. And we have a line here, equator, according to the Earth's equator. And most of the motions in the sky during the day is due to the rotation of the Earth, which means that there is a very natural coordinate system one can use, which is the equatorial grid. That can be easily visualized here as well, where you define the zero, the pole. So in altitude and azimuth, the pole was defined directly overhead, and the opposite pole was directly under your feet. Here it's defined according to the Earth itself, which means it's an absolute coordinate system, which any two people on the surface of the Earth can agree upon. It's the same for them. So because the location of this point will always be same for everybody. It may not be visible in the southern hemisphere. It's still the northern celestial pole point. So if we define this as 90 degrees north, then you'll have the equator, the celestial equator, here as this one it says here. This will be 0 degrees. And then you can go down to 90 degrees south. That will correspond to the south celestial pole point, which won't be visible from the northern hemisphere, only from the southern hemisphere. That would be your 90 degrees south. So 90 degrees, 0 degrees, 90 degrees south, just like our latitude on Earth. So we have this latitude 90 degrees north defined at the North Pole, and 0 degrees all around the equator, and 90 degrees south at the South Pole. Then what you can do is you can define the right ascension. Okay, here what we would do is we would call these degrees what we call as latitudes. Here on the sky, if you're referring to position on the sky, you would call it declination. So declinations would be defined from the celestial equator. Can go down or up, so it will be plus or minus 90 degrees, in degrees up to 90. Now the next thing is we want to define 0 on the equator, and then start measuring the right ascension, which is the other coordinate that we need. We need 2 coordinates to define all points on the surface of the sphere. So the way you do that is you use the sun. Remember the path of the sun that we saw, it goes all around the sky. Now this path of the sun is also called the ecliptic. Now what we'll do is we'll turn on this ecliptic. We go to markings, and this ecliptic 2000. So you'll see this line that does not go parallel to anything, and just you can this is the straight line, and let's see where the sun is right now. Turn off our ground. Yeah. So this is essentially an imaginary line drawn for the path of the sun. You will understand what this particular ecliptic is if you try to see, if you realize, you can check it yourself. If you try to track the motion of the planets, you'll see that all the planets are essentially near or on the ecliptic, which will give you an idea of what this physically represents. This is part of one of the worksheet questions. You can do it, and we can discuss this later. I'm sure you guys will get it. This ecliptic line, for now, you can just, if you don't actually know why this line comes about, you can just imagine this to be an imaginary line on the sky where you can find the sun. So the sun cannot be in any random constellation. It can be only in one of these 12 zodiac constellations along this line, which is the ecliptic. And if you, okay, we have the equator as well. So you'll see that the equator is the 0 degrees line. Let me make it prominent by changing the color. So blue, I don't know, green. Okay, now it's at least stands out from the rest of the grid. Now you can see that, you can play it and see as well, but the sun will cross the celestial equator 2 points. And I think even Shamak talked about this on day 1. And you take one of these points of this crossing, equator crossing, as the 0 hours of right ascension. And again, you'll go eastward to define the positive hours. In this case, it's converted to hours. It's essentially 360 degrees divided into 24 hours. So that 0 or degrees is 0 hours or 24 hours. And every 15 minutes is an hour. Every 15 degrees is an hour. Yes. And if you remember, this is a point that sometimes is referred to as the first point of Aries. This is this is where the sun will, as the sun goes around the year, it will move from below this point to above this point, above the equator. So you can see it will go below. Then about 6 months later, it will go above. You can later note down which months it will do that, and that will be the same. So, I mean, that's how people have defined the 0 point like 4,000 years back or so. And we pretty much use that because it's good enough for your use. This is how the 0 is defined. So you can see how any point on the sky, now using this absolute coordinate system, which is the right ascension and declination, we can define essentially the angle away from this first point of Aries a particular star is, and how much above or below the celestial equator the particular object is. For instance, a random star like this. Okay, it's not a star. This is a star. You can see it's very close to the equator over here. The first line is over here 10 degrees. So you can see it should be slightly less than 5 degrees declination. So you can see here it's 4 degrees, right? And it's about 2 hours. This 4 hours, a little less than 3 hours in right ascension. Or I guess it looks like that because it's, if you see it like this, it's more obvious. It's beyond 3. So 3 hours in right ascension. So this works as well. So we have these coordinate systems, the azimuthal versus local, equatorial, which is more universally we can use. We can convey a particular location of a particular object to someone from across the planet, and they will see it at the same place as long as they properly use the equatorial system. Okay. There was a small exercise where we'll look at something called the Galactic Coordinates. You can try to see where the galaxy is. We will keep the ground off. But you can see that there's a whole bunch of, I'll turn off the deep space objects. You can see the Milky Way here. I'm sure many of you, if you have been to somewhat decent dark sky somewhere near the highway, you would see the Milky Way, would have seen the Milky Way. It looks pretty neat. And the Milky Way, I mean, you can see it in the sky and one can define a coordinate system using the Milky Way itself. We have found the center of the Milky Way galaxy where a supermassive black hole exists. And we define that to be the 0, get rid of the other coordinates. And then we define a galactic North Pole and galactic South Pole, and again, galactic latitude, longitudes. We call it latitude and longitude for galactic coordinates. And that can also be used, especially useful if you're doing large surveys and your interest lies beyond our solar system. We want to look at how the distribution of stars or various objects is in the galaxy. Then it's better to use galactic coordinates rather than equatorial coordinates. Okay, I think we are above time, so I will take some questions, and maybe if I can, a few things, maybe I can cover it in the next session. Okay, Saksham.
Yes, sir. So I had the question that whether Stellarium has like long enough time scales to consider Earth's precession as well. Does
You can check that yourself, but it does. That is why it makes this distinction that something is J2000. So this RA index J2000 is according to where the pole was pointing and where the. So you can see that the definition of RA index depends crucially on where the pole is and where the equator is. And if the Earth is precessing, this changes. So what we do is we try to define coordinates according to where, a particular direction the pole was pointing on a particular day. You have to be that specific. So this RA index, you can see that there are two, if you see the screen, any object, they will list two RA index. One is on J2000, that is according to where the North Celestial Pole and the equator was, I think, the first day of of 2000, year 2000. But since then, it has shifted 21 years on, and that is visible over here. There's very minor changes so far, but over time it will add up. At some point, they will define another standard. I think before J2000, there was definitely one J1950 or something. Maybe there was something in between too. So every few decades or so, they will see the current location of the North Celestial Pole and the equator, define the RA index according to that, so that for next few years they can use that. Is that clear? Okay, we'll go to Gaurav.
Good evening, sir. Am I audible?
Yes, you are.
Yes, sir. Sir, I had a question from the Stellarium activity, sir, which was shared to us. Sir, there is a question in the exercise 2.2 from a figure 1. It shows that the star trails of the southern sky by 8 euro, and there is a question that how much is the approximate exposure time of the image? Sir, what would be the answer? Can you please?
First of all, I wouldn't want you to ask direct questions even to me or any of your participants. Might better for you to figure it out yourself. For instance, I'll help you with that.
Yes, sir. But I had if I am correct or not, how would I know?
How do you think we should answer such a question?
So what
would be your way of? How would you go about answering this question?
So,
can you guess?
Sir, I think it should be 24 hours.
Why do you say that?
Sir, because the picture shows here is a complete circles, and it would approximately take the stars to make the whole circle approximately 24 hours.
That's right. So you're on the right track, except you are not, I think, looking carefully at the star trails. What you would have to, from a distance, it looks like it's complete circles. That's just because there are a lot of stars in the picture. If you try to just locate a starting point of a trail and follow it till its end, you'll see that it's not a complete circle. And there's your answer.
Okay, sir. Okay, sir.
Clear?
Yes, sir. Yes, sir. Thank you, sir. I get it.
Okay, Astha?
Yes, sir. Sir, I guess you partly answered a part of my question.
I cannot hear you loud enough.
Am I audible?
Yes, it's better.
I guess you have partly answered a part of my question. Okay. While deciding the ecliptic and equator, there were two options. One is J2000 and other is equator of the day. So what is the exact difference in between them? Because when I marked them, I couldn't see the difference.
Yeah, as I said, the difference might be very small because J2000 was just 20 years ago. So the difference really comes because they take into effects of the main effect being the precession. There's also some mutation. There are things happening that will move the look. So remember, I showed that there is this point that looks stationary for daily rotations. That is the North Celestial Pole point. Now, this point is not always stationary. It's stationary for timescales of days, months, and even a few years.
Yes, sir.
It's good enough. But if you want to really go precise, you'll see that it moves. And there are different timescales associated with it. There's nutation of, I think, few tens of arcseconds in the timescales of maybe even 20 or tens of years. It moves by degrees, many degrees. In the time scale of I think thousands of years. So I think it was.
So J2000 is like prior to precession?
No. It's just that it will keep on moving. We just say that. So you can imagine if we actually make a particular observation of a star in the year 2000, it will have a position according to where the celestial pole was in 2000.
Yes.
So we are just saying that we are giving the location of the star not according to how it is right now, where it is right now, but we are giving it a location as to where it would have been in the year 2000.
Okay.
Because the coordinate system itself changes year by year. So we want to specify even the coordinate system we are using. Exactly. What I'm saying is the zero of the coordinate system, which is this zero North Celestial Pole point, it moves every year or continuously, except the differences might be very small for a few years. It becomes very large if it takes tens of years and so on. So we are saying that. So even now, for instance, here there's a star picked out. You can see the J2000 and the RA decon date changes by what? 20 seconds of RA. That still is big for astronomical purposes. And even a few minutes over here.
Yes,
which is quite significant. So you can see today we cannot measure using the current one and convey it to somebody. Let's say we publish a paper today using exact RA and DEC that we measured today, using the North Celestial Pole point that we see today. Then 10 or 20 years later, somebody wants to look at the same star using the data that we have published. If we do not mention that this was taken according to how the North Celestial Pole point was defined today, then they'll see a totally different star at that time. So we might want to say that we do it this year, except that if everybody publishes saying that, we are doing on the day we observed, then it again becomes more of a hassle to go check where the whole coordinate system was on that day. So this is just a time-saving efficiency feature where astronomers agree that all publications that we make would use one of these standard epochs. The current one, the latest one being J2000, and it's whenever people publish, they'll use the J2000 epoch to define the position rather than the current one.
And so, what is the purpose of this? All the three check boxes?
If you hover over it, it will show you the things. The one is for the line itself. You mean these, right?
Yes, sir.
So if you hover over it, it says show equator. It shows the line or whichever thing you're trying to see. The other one will divide it into various, essentially using a scale for it. It will cut down that particular line into various subdivisions. The third one will label it. So if you have the meridian, and if you do not want labels and the graduations, you'll see that it's just a plain line. And you can turn these on, just makes measurements easier.
And yes, sir, last one. I can see that there are some SIMBAD readings here. So can we really reuse them for research purposes?
SIMBAD readings, which ones? Oh, you mean here?
Yes. I could see
you
SIMBAD.
mean in the details over here?
Yes, sir.
I would say they try to update it quite often, and they access these values from data that is available directly from there. But I would assume if you're going to use something for research purposes, it's better to go to the source. And these catalogs, it's better to go to the catalog itself rather than use this.
Oh, okay.
But for a quick work, you can always rely on this. I think these are pretty accurate.
Mm-hmm. Okay, sir. Thank you.
Nikhil? Nikhil, you have a question?
Yes, sir. Am I audible?
Yes, you are.
My question was like if I want to go on a particular astronomical event, let's say if I want to see a planetary alignment or next solar eclipse for my place, can I go do that with this software?
I don't know whether you're directly. I don't know whether you can directly search for a solar eclipse on your location, but you can definitely go forward in time and then try to see when it can happen. I don't know. Maybe there is something hidden in there that one can use. There is something called transits. These are essentially. So yeah, the short answer is I don't know whether you can directly search for it and find such events. I'm sure, Google can help it much better. If you're just looking for a date, just Google it, find it out. And if you want to simulate it and see, just come back here, use that particular day, and you'll see that you can simulate it using Stellarium. But independently, whether it can give you that answer, I'm not entirely certain. Okay, so I think there are no more questions. I see a whole bunch of questions in the chat box, but not all of them are relevant to be discussed here. Either you can raise your hand right now and I can quickly answer, or you can always raise it in that either in that activity page or in that form. What I'll try to do is if there are things that needed to be answered even before the second session, then I'll try to answer them and put it in that activity page even earlier than that, so that you guys can get it all cleared. So you can always raise those questions over there. Okay, if there are no other questions, I think we'll stop here today, and then we'll join in, I think, 2 weeks' time, next week. Thanks everyone for joining.